Okay, so welcome back. I'm saying welcome back quite carefully because you may not have seen me yet. So my name is Christopher Franz. I'm also teaching on this paper. So I have been escaping that duty for the past few weeks, but now you have been, yeah, in full statue and so on. So and we tech team a bit with respect to programming. There's Marius as usual, and me looking at other stuffs for probably also programming, but mostly Linux and infrastructural aspects in the course. So on what was the last session? Fridays?
Yep.
Weekend amnesia? Yep, okay. On Friday, Marius talked about that we actually bring up the assignment soon, right? So we're in week 4 now in the course. Is that correct? Who has been counting? Good, me neither. And it's time for you guys to actually get going with some practical exercise or practical challenges before we talk a bit more about Linux, because as far as I understand, there were some problems still in terms of usage of Linux, and that's not surprising. You have been exposed to it for like 3 weeks, some of you a bit longer, some nodding here and there, but okay. So we talk a bit more about Linux particular file system aspects. But before we do that, as promised, we'll highlight the assignment briefly. So it's not really linked in the wiki yet, but if you go to the wiki and you look at the right side, you'll find...
I linked it.
Oh, you linked it. So it's linked now on the main page, on the home page in the wiki. And you'll find the assignment there. And the idea is basically that you develop an online service for browsing a very specific, probably standardized file format, which is reflects well Marius' favorite hobby, which is paragliding. And the idea is there that's a standardized format that captures flight tracks. And luckily, and that's probably why he possibly chose it, there's also a Go library for dealing with this particular file format. So you don't need to become an expert in paragliding or the like, but you want to become more comfortable with including external libraries and using them for generating simple web services. And the whole idea is basically that you host your own web service that allows you to retrieve information about particular tracks, so tracks that have actually been flown. Marius, correct me at any time, in case I do.
Very well.
Okay, that sounds good, sounds good. I used the diving analogy, and I imagine that is quite similar.
We'll do diving next time.
Oh, diving is next time, okay. So everyone who fails that course, 2019 diving. But anyway, for now, 2018. So the idea is there that you can query that service with respect to particular tracks by providing URLs, IDs of individual tracks, if I get it right, and you see a pretty standard specification of how such an API would be encoded. So there's this root directory that runs on a particular host, in this case localhost 8080, which will of course be different because you'll be hosting it on Heroku, at least that's the plan. And then that you have different calls, different REST calls. We talk about REST on Friday. Did anyone hear about REST before in any other course? Yes? More professionally? Yeah. Anyone else? And if no is a perfect, cool. That's cool. We talk about it on Friday. I'm just preparing you what you would see as part of the assignment. That you basically have an interface specified in a standard way that allows you to that specifies requests that you can send to such service and the response you would expect. For example, you're sending a URL and you expect an ID back, things like this. So basically, think about it like a function, and you're modeling input against output. And the idea with cloud computing and web service development in particular is that you learn how to implement against a given specification, right? So and you do that in Go. So there's 2 components there. On the one hand, you're learning to implement in Go. On the other hand, is to learn and read those specifications and perhaps write them yourselves. Because in some cases, you may have the flexibility of changing those specifications or filling gaps in the specifications as well. Because we intentionally, at least that is the idea, leave some gaps here and there where your kind of critical judgment is challenged and asked with respect to solving the issue. So the idea is here that you have different of those tracks, those flight tracks, and you can either retrieve them in a collection, so all the different tracks that are associated with a particular location or a particular track, and then you get the entire detailed information in this kind of form, for example, back. and so on. So that's basically roughly the idea. I will ask you, without going further into it right now, in your spare time, so this afternoon or in the next few days until Friday, to read through this and see how much you get out of the specification. And it will make much more sense when we talk about, on Friday, when we talk about REST services, because that will complete the technical picture of what you're seeing here right now. But it's just more for sanity check, and that you get a better understanding of what the assignment will be about. So basically, you're creating a service that has some sort of input and allows you to decompose, flight tracks in this particular case, and retrieve them individually or as a collection, meaning multiple at the same time. And from the formal perspective, we ask you to host your solutions on some publicly accessible or semi-publicly accessible repository service. So that could be our GitLab, for example. You all have privileges to host your own repositories there. That may be clever if you, for example, want to keep it, from the public eye at this stage. Perhaps you want to put the more or less final version on your GitHub or something, or you feel like you're in any case don't want to share it. Then you can use this one. Alternatively, of course, you can use GitHub, Bitbucket, the proper GitLab. When I say proper GitLab, that's I think Mariusz may have talked about this. GitLab is amongst all the different Git services or repository software versioning services, is the only one that provides its platform open source available for you to host on your own, right? So that's what we're doing. We're hosting our, sorry? No. We're hosting our own GitLab solution for this very purpose here, but it's also available in a proper hosted fashion as gitlab.com, so you can have your own account there and host it there as well. Please don't confuse the two. They of course look the same, but the credentials will certainly be different. So when you provide us with your final repository URL, just ensure that it's accessible to us. Or if you want to keep it private, you can make us collaborators. We are pretty much on all those platforms as well. So Thomas, Björn, Mariusz, and I, we are all represented there, so you can invite us with our respective identifiers. The assignment is relatively simple, and that's why it's only worth 10% of the course for now, right? So that's the first assignment. We take it slow. It's mostly about you becoming comfortable with dealing in your development environment, figuring out, how you use things and integrate it with Git. So find your workflow and so on. And the next assignments in part may build on this one. We don't know it quite yet because we haven't even thought about the next one. But they will certainly rely on you having a properly set up environment, so you're a bit more productive the next time around. That's why it's only 10% for this one. And this corresponds to 25% of the entire internal portfolio, your 40% that you are graded for your internal projects, and then the 60% will be the exam, which, in all apology, it's a big chunk. We would have liked to change it, but it was not possible at this stage. So for next year, we hopefully get that done. The deadline is in October 14th, for October 14th at midnight. That's a Sunday. Cleverly chosen, my friend. So I know how I waste my weekend on that day with all those last-minute questions about how do I do this and that.
We don't respond to questions on the last 2 days of the assignment.
Exactly. We don't respond to questions on the last 2 weeks of the assignment. That's right. No, of course not. But so Sunday it is, midnight. The idea is that you guys do your time management yourself, right? So it's quite a way off. But so, I mean, you could, of course, submit it anytime earlier. You can do anything until that deadline, because the only thing that we need from you for your submission is the URL to your repository, right?
No, two things.
Two things, there you go.
So we need a URL to your repository, and we need the URL to the deployed app.
Yeah, okay.
Yeah. So
That's right.
Two URLs. Yeah.
That's right. So we'll have a submission system that allows you to provide this. And last year I had a bit of a drama because the system was a bit overused by 80 students trying it at, I guess...
Last minute?
Yes, 11:55 onwards. So it was down a bit. So if that were to happen, meaning you're late in the submission system, it doesn't really matter because we will look at your latest commit, right? So if the latest commit counts, and if that has happened before the deadline, you'll be fine, right? Just saying that in advance. No? Okay. Anyway, you'll see it then when it happens to you, when the system is down. But until then, you can also, of course, submit your URL for your repository early, right? So it just means you can work until last minute and and then we'll just check and take the latest commit. That's the key idea.
Because both URLs will be exactly the same at the very beginning of your work, and then once you're done, the URLs don't change. What changes is the content of your repository and the app that is deployed. But the URL to the app and the repository URL are the same. So you can submit your submission like, you know, tomorrow, and it's empty, and you keep working on it until the deadline. So you don't have to submit in the last minute. You can submit, you know, now. Not now because we haven't opened the submission yet. But,
don't. It's offline again.
Yeah.
So it means we want to de-stress the submission a bit, and you should do it early. It's in your own interest, and you can just concentrate on the coding and not on the submission, which is like often tedious, especially if deadlines are involved.
Questions about this?
General questions apart, of course, from the details, because I will ask you to read it on your own. Any questions?
Yeah, I was wondering, if you want to do the crawler, you have to do the other assignment as well?
Yes, that is a discussion that we had.
Yeah.
So it's not a substitution exercise; it's an additional exercise that you do. It's twofold. I think we take our latest interpretation of that.
Yeah.
So the assignments are all mandatory; you need to do them. But on top of that, Myrish, in this case, offered you a code challenge already, and there will be more challenges that you can do on top of it. And the idea is not so much that you get dedicated marks for it, but rather that you actually hone your skills, and that will feed back in the assignments themselves, and possibly in any further assessment, including the exam. So that's the key idea. But the core of this course will be those projects that we're doing here. And we mentioned the social component. So your proactive contribution to the course includes both, posting issues, participating in the review of others' work, but also in class, as far as we remember. They may actually help you bump you over a threshold if necessary. But they will, of course, not be super decisive, getting you from a C to A. That's very unlikely. No, it's
that's
impossible. Unlikely. It's not an appropriate term in this context. But if you are sitting at a borderline grade, that will help you. Other than this, it's really about honing your skills, because it may come back to you in the group project or the exam.
Yeah, if you have any questions or clarification questions for the assignment or for the code challenge, please make an issue, and then we can sort of discuss it in the issue tracker. There was already one. Someone emailed me a question. I put it onto the issue tracker, and then it leads to modifications of the specification for the assignment. So if you have any comments or suggestions or questions, then use the issue tracker.
It would be really good to document as much as possible on the issue tracker. And again, it falls down to contribution at the same time, but also laziness on our part. So actually, if two people have the same question, then it's probably also already answered in the issue tracker. Because last year it was quite prevalent that we had a lot of emails with
about
similar.
the same thing.
And it's oftentimes more helpful if you actually look at issues and contribute, or extend them, or say I have the same problem, but I have different environment set up or something like this. That's generally quite helpful. And we already have two quite helpful issues here, very related to the course, and one of them quite proactive with respect to Go setup. So that's very good. Cool. Any other thoughts right now? Of course, we can ask questions later again, but please.
Is this a one-person assignment, or can you?
That's for now. It's a one-person assignment. So assignment 1 and 2 will be individual assignments. So you hone your own skills and show us what you can do. Whereas the last one will be a group assignment, where you work in pairs of 2 to 4, ideally. 4 is already big, eh?
Yeah, 2
but
3.
Yeah, 4 is borderline, but we can scale it up, of course. Or you can scale it up. You can also say, hey, since we are more people in that group, we do that additional bell or whistle, right? So we can negotiate on that a bit. So, but we don't want to make it too big. But the idea is that you both have an individual part where you actually show what you can do, and it feeds into your mark, and a collective one where you actually show, okay, I can work with others as well. Because in every course we encourage the collaboration aspect, because you need to do it for your bachelor anyway, right? So not having most likely not your own individual bachelor project. Other thoughts? Okay, so yeah, you probably need to take some time to read the assignment eventually, and then we go from there. Cool, without further ado, back to our favorite topic, that is Linux, I suspect. So, last session...
Before you start, today we'll do Linux, and then on Friday we will do REST services and some
Yeah, we do specifications,
additional things, and then we go back to Go next Monday, most likely.
Yeah. So your last chance to leave if you're inherently not interested in infrastructure and only want to hear about Go. But I encourage you to stay, because if you look at cloud computing, it boils down, and we haven't gotten to that stage really yet. When you use infrastructure, it always boils down that you need to have some sort of command of Linux. It's impossible to get away with only Linux, Windows skills or other operating systems. It's just that Linux is so predominant in that space. As you probably heard from Mariusz in the earlier session, that pretty much 100% of all supercomputers only run Linux or some sort of Unix derivative anyway. So it's quite essential that you have a solid grasp of that. As far as I understand, you got as far as to do a quiz, like in the last Linux session that you did, right? So, and we continue a bit on there because I heard that there were still some people struggling with the command line a bit. Is that still the case? Or are people very somewhat comfortable with command line challenges? Who finished their Go setup completely? 1, 2, 3. So it's the majority. It's majority, let's say 55%. Okay, a slight majority. So, but perhaps to provide a bit more clarification on how that actually works, we're talking a bit more about the file system in Linux. And as far as you know right now, you pretty much have seen a console and you enter stuff. You can inspect your own home directory and so on, and follow instructions to install Go. But I think for a good Linux understanding, you want to get richer context about the file system. So in the original Unix conception, the idea was that everything is kind of modeled as a file. So unlike in Windows, where you, for example, deal with the device manager for dealing with the drivers and a registry for dealing with additional services and so on, in Linux, the idea was, on Unix rather, the idea was to model everything as a file. So it's you know, a uniform way of accessing any sort of functionality or resource that's attached to your computer. Of course, that doesn't really work nowadays. There, you know, some shortcuts had to be taken. For example, networking devices are not captured as files. But other than that, there is a good chance that the devices that are relevant for your use are actually represented as files, and we get to that in a second. And this motivation, this motto of everything is a file, is represented in the idea of the virtual file system that is provided in Linux. That is an abstraction layer that sits on top of all disk drives, but also devices, but also processes. So if you think about your task manager in Windows, you see all the processes. You can inspect the same thing using tools in Linux, but in fact, it will just inspect files that you can do as well. And we get to that as well. So that's the idea, and then you can access files in an object-like fashion. You can write to them, you can read from them, you can change their permissions, you can possibly delete them. So that's the whole idea around it. So I'm not going much deeper than that, but to make life a bit easier or harder is up to you. The Unix or rather the Linux specification nowadays are somewhat unified around a common file system structure. In Windows, you're used to having probably multiple drive letters, right? Drive letter C, D, E, F for different devices. Everyone comfortable here? Yeah, cool. And in Linux, it's all the same. So the idea is that you have a single hierarchy that captures everything on your, all partitions that you have, for example, in your computer, and the devices and so on. And this thing is called the file system hierarchy. And it starts off with the root, the slash on the far left you see here in this diagram. I think all the screens are switched on. Yep. This is the root, and all navigation starts from there, right? So that's not even the C drive, that's even above the C drive in Windows somewhere, right? So everything else
My computer.
My computer would be equivalent, exactly, right, that's right. So the My Computer icon is roughly where it is, please.
But the root, it's still in a partition, right?
No. No.
No. Okay.
Cool. So, but you hook partitions into it, right? So, so the idea is here that you have a standardized file system and with standardized structure, folder structure that we can briefly iterate through, and then we'll see where other partitions, for example, would be hooked in. So generally you have something like a bin folder. If you open, so I've just opened the virtual machine to give you a bit of a feel. That is usually an exercise that tests whether my machine actually works with the load of streaming and Unix at the same time. So, so, all right. So it may not be super legible, but I keep the I keep the original here, the schema, and you'll see that it's largely corresponds. This blue is a bit ugly here, but we have a bin directory which contains basically user commands that are accessible by any user that uses the system. Note that Linux is made for multi-user use, right? Unlike Windows, where it kind of was patched on using their terminal server services and remote desktop functionality. In Linux, the system was built around the idea that multiple users will work on it at the same time. So the bin directory allows this common access to commands that are available. Boot is not something you need to concern yourself with because it basically just contains the bootloader information, bootloader files, and kernel images that are provided with a particular distribution. Then def is an interesting one. That's device files. That's actually where you find access to particular devices. So let's see what we can see there. It's more
Let's go to disk by.
Sorry?
Go to a disk device, for instance.
That's right. SDA, are you referring to?
For instance.
Right, there you go. So here you have quite a bit of devices. So you have devices that is such as random. That's an interesting one. Any guess what that is?
So the random number generator.
That's right. Did everyone hear this? Right, so it's basically your system levels random number or pseudo random number generator. So quite handy to actually have. You can consume this one, and then you have those here SDA 1, 2, 3, 4, 5, and so on. And this is actually your hard drive. In this case, SDA would correspond to first hard drive, SDB the second one, SDC third one, and then the corresponding partitions. So partition 1, 2, and 5. I'm not going into partition system and primary and extended partitions and so on, but this would basically be your hard drive representations. On the same grounds, there's something like TTY down here. I'm not sure if you can read it, that's why I'm just saying to you TTY. Does anyone know what this could stand for? It should ring a bell if you attended the last Linux session, because you should have talked about this. Okay, fair enough. Does it TTY? No one? Good. So it's basically terminals. So you can, for example, log in multiple users, right, on the same machine, and you can access theoretically each other's terminal using this way by accessing that very file, right? So, or posting something to another terminal. It's also very feasible here. So, and in this way, there's quite a bit of functionality that you find here. I'll probably come back to that in a second. I have some other comments I want to make. Good. The rest is not entirely important, but for you important is to remember everything under dev is generally some sort of device. Yeah. The only thing that's not represented there is network devices. You will not generally find them there.
They're normally there as well.
Yeah.
Under some kind of methods directory.
Ah, that's right. There's on the net. Let's explore that. So. That's tunneling device.
Yeah, there is a network device. Normally there is a network device as well.
Yeah. Anyway. So, yeah, we can't. I generally struggle finding those. So, yeah, I believe there must be some way of doing that. Yes. Okay. So anyway, let's follow the structure further, just to, because you will not need to access it, but you'll find this on any Linux system, the dev folder, right? So it just means that it may be useful for accessing some sort of hardware or reading your random number generator or the like. So the next folder, that's probably amongst the most important ones, especially if you're an administrator yourself, is the etc folder. And this one holds all the host-specific system configuration files. So if you, for example, configure your network environment, your DNS service, and applications like a web service and so on, all the host-dependent files will be found in this particular folder. So if you're doing a backup of a Linux system, that is a safe folder to consider for that as well. Following this one is the home folder we'll find in any distribution. That contains the home directories. So one home folder contains n directories, one for each user that is added to the system. So in this case, I think I made up some users in this system here just for the sake of demonstration. So this, that was. So here, you may not be able to read it, but there's user 1, 2, 3, 4, 5, and so on. So they're all handled there. That's also standardized. Libraries folder, shared libraries. Media is generally a mount point for removal media, such as CD-ROMs would be a standard for that one. So often not writable media. MNT is mount points for external file systems. So for example, you have your USB stick, you want to mount in the system. That would appear in a folder under there. So suddenly if you write to /MNT/USB01, that would be meaning you're writing actually to your USB stick if it's mounted properly. Right? So that's the way of how external partitions and functionality is integrated in Linux. And so on. So we have the opt folder, which is sometimes existing, sometimes not. Then there's the SBIN, that's system binaries. So that's binaries that are essential for the administration of the system. And for using it, but not necessarily relevant for every user. And this is the difference to the bin directory up there on top. Server, in some distributions you find SRV. That is, the idea is to put any services that the system provides, the executables in particular, into this folder. But really depends on distribution, how this is handled. And generally you don't, again, need to be concerned with this really, because the distribution-dependent repository manager or application package manager will do that for you, right? So you heard about apt-get. Did they hear about apt-get?
Yep.
Yes, cool.
Not formally.
Not formally, but you used apt-get, right, for some installation probably, right? So this thing basically, you tell it, okay, I want to have this service running on my Linux system, and apt-get will just install it and run it. But it knows the distribution and the file layout of your environment and does it for you, so you don't need to be concerned about it terribly. But sometimes you need to have access, for example, to log files and so on. So it's better, you better know where they are actually, right? So that's the key idea. Cool. Temporary directory, nothing much there. User installed applications. The var folder is oftentimes quite relevant because it contains log files in particular. So variable files folders. So that's generally where log files are held. And the root folder is the home directory of the root user. So note the root user has an own directory that's separated from the home directories of all regular users on the system. And the reason for that is quite is mostly that the home directory is often hosted on a different hard drive or associated with different hard drive than the actual main system. So this case, you can ensure that you have the home, the files of the super user available even if the external hard drive is not available, for example, right? You're using user data or you're exchanging the hard drive there, you still can use the system using the root user. That's the key idea. And last but not least, the PROG directory, which hosts all the processes in the system. So this is what I mentioned earlier, that you can actually access all the individual processes in a system. So if you go to that folder and run ls, you'll see that there's quite a bit of files in there. And all of those are basically just processes that are running in the background of the system. And here in those folders, you'll see those are the process IDs associated with them. Once you hear operating system, I think in your fourth semester, you will talk about process management and the like. And this is the reflection how it's done in Linux, basically. And I believe you dig much deeper into it at that stage. But again, it's just to highlight that Linux has a bit of a different philosophy from Windows in that it kind of tries to unify everything in the file system and makes it available there. That's an interesting one. Okay. Yeah, anyway, okay. So, any questions? That was a bit of a waterfall here. Sorry for that in the first place. Any questions regarding this? Yeah, you have a question?
No, I'm just pointing out that we haven't talked about the package management. We
Yeah.
just mentioned that different distributions have different
Yeah.
ones. And we didn't talk a lot about terminals and
Good.
shell access and...
Good. We get there. We get there.
Okay.
Cool. So, yeah. So what I did here, you all saw shell already, right? So you had some terminal access already, right? And we're mucking around a bit there. But we structured the approach quite a bit. But I first wanted you to have an understanding what all those folders, where they are all coming from, what their purpose is, and so on, right? So, and note again, this will vary by distribution. So if you run in Ubuntu, you will see a slightly different layout than if you run compared to a Fedora that you may be running or some other distribution. So it depends a bit on the distribution, but the idea is that this is the convention any distribution should follow if they decide to do so, of course. There's no law, it's a normative environment, so that distribution providers say, yeah, let's do it and follow this principle. Okay, so this is the file system. So generally then, with all those folder structures, so that was the first layer, first level folder structures, we have a bit of a starting point here. But of course, if you store files and you actually have your user data and so on there, then things can become quite a bit different. In that you of course have a bit more of a hierarchical view here. For example, here's the slash, which is the root directory, then the home directory, and then two users, Jim and Jane, that all have their individual data, right? So Jim has a subfolder called the calendar, and a subfolder with other months, and then files that represent dates, and Jane has roughly the same thing with other, structural elements here. There's another top-level folder called work, which again has some other elements. So the idea is now, how do we actually navigate meaningfully across this? And one of the key characteristics, which you also probably know from the Windows world, is absolute versus relative path. Did anyone hear about this before anywhere?
Absolute and relative path.
Yes?
A relative path is, for example, if you want to access some sort of file within a folder and the other file that you want to access, it's in the same folder or in a folder that's in that folder again.
Yeah.
And an absolute path is if you go like disk C / and then you put the whole path in it, and that's an absolute path.
Very nice. Yeah, exactly. So precisely like this, it basically boils down where you start, right?
Yeah.
So that's a very good point. So if you're starting from a perspective of a particular folder, as you mentioned before, for example, calendar, well, a relative path would mean I'm moving one level up, for example, to access Jim, or one level down to access the file output, right? If I use an absolute path, I always start from the top, right? So unambiguously from the top, I say /home /Jim /calendar /October /1, right? So 1 is the file in October. So this would be a relative path starting from the top. So if you ever were to access, for example, were to want to navigate to Jane's data from Jim's calendar, you would do something like, the point is all the folders or the relationships of the folders are represented by symbols. So in the system, for example, a current folder, the symbol dot or full stop in the console means current folder, right? So I'd probably try that best by demoing it on the command line. So if I say, just some context. I'm now on the top level. The font is a bit small, but what I'm doing is I'm showing all the main directories again, right? So, and I'm using a command ls, and the ls does nothing but to list the content of the directory. What is the command in Windows for that? Dir, right? So directory, dir. So it's the same thing. Linux has the ls here, or Unix rather. And but that's basically the same as saying ls space full stop, because it says list the current directory. It's more explicit than the other one. Yeah. So if I were to say ls dot dot, it will still list the same thing. And the reason for this one is that I'm already in the root directory. It can't go up further, so it's listing the same directory. But let's try the same in the home directory. I'm going one level down to home. And now I say ls and see what's in there. There's some stuff in there. The users that I mentioned before. And again, if I say ls space full stop, it lists the content again, please.
Can you turn off the alias for ls so you can actually show it without colors it's a little bit tricky to view the blue on black.
Ah, yeah, blue on black is nasty, isn't it? Yeah, so it's user. Hang on, I could cheat a bit. If I sudo su, may get the password wrong. Hang on. So, okay. Ah, still blue.
Because it's aliased to the one with color.
Damn.
So if you say
Bash LC, right?
If you just say alias, ls equals ls.
Ah, yeah, true, you're right. This ls, and it looks better. Thank you.
Yeah.
So, thank you. So, if we list all the different directories, so user 1, 2, 3, 4, 5. So that was ls, and there's different parameters for showing different levels of details. Which makes sense as if I show you later. So if you say ls space full stop, you see the users again. If you say ls dot dot, it will actually show you the content of the parent directory, right? So this would correspond to actually moving up one level and showing you the content of this directory. So yeah, pointing to a different path there. So so that's quite important to be clear about what those symbols mean. So full stop means current directory, and double full stop means parent directory. And slash always refers to a home directory. If you, for example, say ls slash, it will always list the content of the root directory. Did I say home before? Root directory. Root directory. And another symbol worthwhile knowing is the tilde. So if you say, for example, ls tilde, and yeah, you have showed up all have tilde on your keyboards, then it will show you the contents of your own home directory. So one other command that is probably a bit more interactive is like cd for change directory, same as in Windows. If you say cd tilde, you will change into your home directory. And if you run ls there, you see the same content as I just showed you before, right? And here, if you look at the prompt always reads the user at the system it's connected to, at the directory it's basically it's operating on. And you see that when I'm in a home directory, you see that before the prompt there's a tilde. It signifies that this is the home directory for the currently logged on user, right? If you move out of that one, then it just shows the absolute directory. So, so what does it mean? If we want to do a bit more complex navigation, for example, from navigating from here to here using relative path, we could say something like // Jane / data, right? So if you want to navigate from calendar to data Jane using only relative path. In this case, the key thing is there that there's no leading slash. If you were to use the absolute navigation, you would go down from, again, as I mentioned before, using / home, Jane, data, and so on. So for you, it's just important to be able to identify when am I navigating relative to my current point in the file system, or when am I navigating from the top of the file system. And the simple way of doing that is to figure out, am I using / in the beginning? If you're not using / in the beginning, then it means you're actually navigating from your current point, from your current location in the file system elsewhere. Does it somewhat make sense? Who thinks it doesn't make sense? It's perfectly fine. Often don't make sense.
It makes
Too.
sense.
But, yeah, okay. Else we can come back to that in, if you have a question also, of course, you can come back to me in that break. Oh, perhaps a good acid test is always. So what would be the navigation for the absolute path for navigating to September here? Anyone? What's the absolute path?
/ home / gym / calendar / set.
Cool. Right, so the same thing now from September to sub, for example, using relative path notation. Who wants to go for you as well?
Yeah,
No one else?
I was gonna do the trick, just do the tilde, because then you start at home, and then go Jane, data, sub.
You can use that. Yeah, that's good. Yeah, you got me there. That's a good one. So you, in this case, since we're navigating via home, you can also just ignore this hierarchical traversion here and just directly go to home using the tilde and then navigate down from there. But if you would do it, idiomatically without using tilde, how would you get from, what did I say, October, September?
CD dot dot, CD dot dot.
Yeah, no, but in one command. Yeah.
dot dot slash dot
Yeah.
dot slash dot dot slash Jane slash data slash was it sub?
Whatever. Yeah, sub. Yeah, exactly. Right. So you're queuing basically up. So I'm just, of course, that will not work in this context here. But what you said roughly was like that data slash sub. Right. So in one command you're navigating up 1 level, 2 levels, 3 levels, and you're at home hopefully, and then you're going down using Jane, data, and sub again. Right. So that's relative notation. The key thing is there a leading slash in the beginning or not? If there's none, then it means you're navigating relative path. Good. Okay. So good. So yeah, it's a bit dry, I admit it. So few minutes, then we have a break, and then you can forget everything about what I said, and then we start from scratch. So no, please don't, else we do that again. So we need to make some headway here. So again, coming back to Unix, the point is everything you learn here, it pretty much works for now across all distributions. Right? When we talk about package management using apt, for example, that's specific to some distributions, but all the commands we have seen as of now are inherently generic. Yeah, even on the Unix system, so pre-Linux system, you should be fine with those ones. Cool. So sometimes you want to create files on a system just for demoing something, or for perhaps writing your own script, or just see what's in them. Basically, that's the key idea. And here, that's just a table organizing the characteristics by the CRUD functionality that you know probably from the first year, right? What does CRUD stand for? CRUD? C-R-U-D? Good, exactly, right? So that's the standard functionality you do on any file or any object, really, right? So you either create it, you delete it, you change it, or you look at it at least, right? So that's the idea here as well. So in Linux, if you want to create a file, and that just means an empty file, nothing really special about it, you can just say something like touch. So touch test, for example, say ls afterwards. So here, again, it may be a bit hard to spot, but I said touch test, and you look at the directory, you suddenly have a test file in there. So it just created an empty file. Yes, so inherently meaningful. Does anyone know another use of touch in Unix? It has two purposes. Exactly, right? So it's literally, that's the original connotation to say touch a particular file, right? Touch it meaning just access it, basically. And what happens there, the timestamp is changed of that file. So if you want to update the timestamp of a file, for example, for parsing reasons, you want to see when it was last accessed, you can use touch to achieve that. If the file doesn't exist, the file you want to touch, then it creates a new empty file. Yeah? So similar there, you see this greater than symbol. That's basically redirection. The idea is there that you can create files directly from command line by redirecting into files. So in this case, I'm redirecting the text test, so echo test into the file test. Right? So if you afterwards look at the file test using command cat, you'll see that the content is now in that file. So that's one way of creating files as well. If the file doesn't exist, the file will be created using that mechanism. So for viewing files, we have a lot of powerful commands.
So just a quick side note.
Please.
So when I was doing some coding with Vim, I almost always did touch main.go, and then Vim opened this Go file. Why I was doing that? Why I did touch first?
Again, what was your question?
There's some.
Yeah,
To get syntax highlighting in Vim.
exactly. To already have a Go file, so when I open Vim with this Go file, it knows that to be in Go mode. Right? If I opened Vim and then start typing, it wouldn't know that it's a Go file, right?
You actually don't have to touch the file before you start using it with Vim. If you just say Vim dash or space main.go,
Yeah,
you'll open it, and you'll still get the highlighting.
that is correct.
You
Yeah.
don't have to create it first.
Yeah, so I have this old habit for the reason he said, but I don't need to do that. Yeah. Okay, carry on.
Habits die slowly. Anyway, yeah, that's good. So, but just to have some commands handy at your discretion. So, yeah, enough touching now. So we looked at viewing files. So the standard command is cat. right? So what does cat do? It just spits out the content of the file. Why do we need more commands? Why not just with cat and we solve all the world's problems by looking into files?
Some files might be a little bit bigger.
Very good. So yes, so that is exactly the point. In Linux, often if you do something on the command line, of course, it may relate to programming sometimes, but also manipulating configuration files, but more often than not, you look into log files. And log files have one thing that is characteristic about them, they are huge. So I'm just, well, for the system size, so let's do that. We have a syslog file.
-h to the ls there, you can get the 2 millimeter.
That's right. Like that?
A dash.
You can combine it, right? There you go. The human readable variant, thank you. And we were, so it's not terribly large, but my favorite one is generally syslog here. So I went into the directory /var/log. As I mentioned before, that's very variable files like. And then the subdirectory log, you'll find the log files. And one of them is, which is quite handy, that captures all the main system activities, the syslog, and it captures, for example, 2.1 megabyte. If I run, for example, cat syslog right now, it may take a while until you actually go, get where you actually want to get to. And that's why there's something like a head, for example, that allows you to quickly only see, the first 10 lines, or something like tail that allows you to see the last 10 lines where relevant. So that's one of the ideas. Less, if I recall correctly, is an interactive version where you can actually scroll per page, right? So yeah. Cool. By the way, if you run something, that's always good to know. That's the only thing you actually want to know when you deal with Linux. If you run something, you want to interrupt it. What do you do?
Control C.
Control C, right? So you terminate the process. Sometimes it's more relevant than not. So yeah, cut is to inspect files on a formatted basis. Oh god.
Yeah, so quick two notes about the termination. What are the termination control something you know?
Yeah.
Logout, Control D.
Yeah.
Mm-hmm.
What else?
Do you think about end of file or no?
Yeah. So what is end of file?
EOF, which is like it's just a signal that it's the end of the file. So
Yeah, but Control D also is. So Control D kind of feeds that, okay, there will be no other input coming in. So Control C kind of sends the kill command to the process. Control D sends, okay, there is no more input to the process, and Control Z puts the process into the background, and you can bring it back to foreground with FG. So those are three kind of control useful things. So sometimes Control D quits, like if you're in some sort of interpreter. Often Control C does nothing. You have to say, okay, there will be no more input, so you have to do Control D instead.
Yeah. So that's process signaling. Good. We could talk about the kill command later as well, which is like basically what you just said you're going to use if you want to send a command to particular processes.
Sync kill.
Sig kill, yes, exactly. So yeah. Cool. So we do a bit of a break first because I realize it's now 3 p.m. So let's start back at, what is it? I don't know. Is 5 minutes enough for the average student, or do we need 10 minutes?
10 minutes.
Oh God. Okay, you got me. And 3:15.
3:15.
No
Zack.
break. Keep going.